Hello there. Thank you for clicking on this video. This is the practice set for the lesson on multiplying radicals and a review of other operations, as well as what was covered in the lesson. A little division. So we had a little bit of division in the lesson as well. Please like and subscribe for more math help. Drop a comment or a question to engage, and check out the other videos and playlists on the channel. There's stuff for Desmos and algebra tiles and multiple choice questions, as well as a full range of Algebra 1, and at the time of this recording, a big chunk of Algebra 2 as well. As always, pause the video to work these problems on your own, and then come back to check your work. Okay, so these first ones, starting off with some pretty basic multiplication and division. In the first one, we do want to look to see if we can simplify ahead of time. That's an option, but neither of these can be simplified. So we go straight to the square root of 2 times the square root of 6 is the square root of 2 times 6, which is, of course, 12. And then before you're done, you do want to check to see if it can be simplified. Now, if you can simplify in this in your head, you can go straight to the 2 root 3. Okay, I've done enough simplification that I know that that's going to simplify to 2 root 3. Now, if you're wondering, well, how did she do that? If you grab the prime factorization of 12, that will factor into 2 times 2 times 3. And because it is a square root, you're looking for groups of 2 or perfect squares. And so the square root of 2 squared is 2. And so there's where the 2 on the outside comes from. On the second one, we're taking the same things and we are dividing them. So the square root of 6 divided by the square root of 2 is equal to the square root of 6 over 2, which is the square root of 3. And you would want to do that division out. So there we have it. Okay, first 2. Now, I did mention in the lesson, and it was on the title slide for this practice set, that we would review the other operations. What I find with my students sometimes is if I give them all adding problems, they're fine. If it's all multiplying problems, they're fine. But when you mix adding and multiplying, then it becomes more of an issue. Now, before you can add things, we need to remember that you can only add like radicals. It is different from multiplication, and I encourage you to go watch the video on adding and subtracting radicals. If you haven't, if that feels like a random rule to you and doesn't seem to make sense, please go check out the lesson on that. Now, we do need to simplify the square root of 8 to see if that will factor in or will simplify to match. So 8 factors into 4 times 2, and the 4 factors into 2 times 2. So that's 2 times 2 times 2. We're, of course, looking for perfect squares. So I see a 2 times 2. We're looking for those groups of 2. So that simplifies into 2 root 2. And essentially what we have there is 1 root 2 plus 2 root 2, which will give me 3 root 2. Now, on number 4 here, you've got some options for how you'd like to do it. You can multiply and then simplify, or you can simplify and then multiply and then maybe have to simplify again. Kind of up to you. I'm going to go ahead and multiply them and then simplify. So this would be the square root of x to the third times x to the third. And you can do this a couple ways. Honestly, you could do the x to the third times x to the third, which would give you the that, which is x to the sixth. But what you would end up doing, so if you do that, then what you'd end up doing is just breaking it back down again, like x times x times x, and so forth. So what might be easier to do is, instead of combining them with the laws of exponents, just go ahead and get that prime factorization, because that's where we would be headed anyway. And then we're looking for groups of 2. So I see a group of 2, a group of 2, and another group of 2. The square root of x squared is x, and then I have another x and another x, okay, because we've got it 3 times, which would be x to the third. If you did this by simplifying first, okay, so you got the square root of x to the third times the square root of x to the third. I don't know why I put the index in there, but sure. So we have x times x times x times the square root of x times x times x. We're again looking for those pairs. And so we would have x root x times x root x. Okay, x times x gives me x squared. The square root of x times the square root of x would be the square root of x times x, or x squared. The square root of x squared is x, and you land in the same spot. I think that's more work. That's my personal hot take. I think it's more work to simplify first and then multiply them, because what ends up happening here is we end up having to simplify again. So we can simplify, but then we end up with the square root of x squared, so we have to kind of go through the process again. That's really personal preference. Really personal preference. You're not wrong to do it a different way. Just, with some experience, you might find a faster way to do it. All right, back to division. So for number 5, we have the cube root of 54 over the cube root of 2, and you can do this by simplifying the cube root of 54, but 54 is kind of starting to be a bit of a big number. Can I go get the prime factorization of that? Sure, I can get the prime factorization of it, but it is, a bit of a mess. So I'm going to go ahead and just say the cube root of 54 over 2. So you do 54 divided by 2 goes into times 14 is 27. All right, so we get the cube root of 27. And you might remember, if you've done like sum and difference of cubes, that 27 is 3 to the third power. And so the cube root of 3 cubed is 3. If you opt to do the simplification first, this is what it ends up looking like. You would have to break down the 54. Now, we just kind of did that. We did that into 2 times 27, and 27 factors into 3 times 3 times 3. So you end up with the cube root of, copy that over. That, however, is not what the problem was. So let's try that again. Cube root of 2. So you end up with the cube root of 2 times 3 times 3 times 3 over the cube root of 2. We are, of course, looking for that perfect cube there. So the cube root of 3 cubed is 3, and then you have the cube root of 2 over the cube root of 2, but anything divided by itself is 1, canceling that out and leaving you with the 3. So again, both of those methods work. As I said in the video, the expression "pick your poison," whichever way you think is easier. I tend to want to shrink the number down if it's possible for me to get a smaller number. I can avoid this over here, that doesn't make me happy in my heart. All right, number 6. So this is a subtraction problem. And, if you were playing the multiple choice game here, you would know that the answer is negative. So even if you don't know what the square root of 27 and square root of 81 is, you know that whatever it is, it's going to end up being negative, like the square root of 27 is smaller. All right, so let's see what happens with this. So 27, we know factors into 9 times 3, and 9 factors into 3 times 3. So the factorization of 27 is 3 times 3 times 3, minus, we've got 81 factors into 9 times 9. Now, the square root of 81, hopefully is 9. But we'll go ahead with this. And of course, you can now see even clearer that that the first one is smaller. So we're looking for the pair there. The square root of 3 squared is 3. And over here, we have the square root of 2 groups. So 3, we have the square root of 3 squared is 3 times another one. And now we're done. Okay. And so that one is one that turns out that we actually can't do that much with it. Yeah, we cannot do that much with it. So we get the 3 root 3 minus 9. We don't have the matching radicals. So we're done. All right, let's look at some that have some variables in them. So here we have the square root of xy times the square root of y. Well, when I multiply that, that's the square root of xy times y. And without multiplying it together, we know that's a square root. So we're looking for that pair. The square root of y squared is just y. So that would be y root x. If you have a teacher that is wanting to make sure that you, I would say like you put your absolute value around it, but that's going to get messy. Because they were separated in the first place. I need to like think about that. If y is negative, you're going to have an I at play in 2 different radicals, and then the I squared would give you the negative. I think I would leave it. But I'm also kind of doing that really fast. All right, the 8. So we've got the square root of xy over the square root of y. So that would be the square root of xy over y. Anything divided by itself is 1, assuming that it's not 0, which is safe to assume there because it was in the denominator to begin with. So that would just be the square root of x on problem number 8 there. And moving into our last few problems, the square root of 27 plus the square root of 16. This one is going to be similar to the one we were looking at before, which makes me think that I miswrote one of those problems because I think I intended for one of them to match up, and it doesn't. And this is where we want to have some long-term memory. So the square root of 27, we just did that. That is 3 root 3. Okay, so that's 3 root 3, and then the square root of 16, I hope you know, is 4, and like we're done. Okay, so we can't go any further than that. And for our last one, we have the cube root of x to the 4th over the cube root of x. And as with the other division problem, like we could go through the process of simplifying the cube root of x to the 4th, but it's probably going to be faster for us to do the cube root of x to the 4th over x. Well, x to the 4th over x is the 4x's divided by an x. One of them cancels out. Well, there we go. That's a little bit better. Leaving me with x to the 3rd, and the cube root of x to the 3rd is just x. If you were to do it the other way, you would have the cube root of x to the 4th. So that would be the cube root of 4x's, which of course we'd be looking for that group of 3. Which would give me x cube root x over the cube root of x. And then anything divided by itself is 1, which means those would cancel out, leaving me with an x. There you have it. So there's all 10 problems. Hopefully that gave you a good review of the concepts, as well as some simplifying of the radicals, refreshing what you should know about adding and subtracting radicals. Don't forget to like and subscribe for more math content. If this was helpful, if this clarified, please leave a like, let me know. Leave a comment or question. Again, let me know if this helped, if this was helpful for you, or if it wasn't helpful, what was confusing about it. And then check out the many other videos and playlists on the channel I mentioned earlier. We've got all kinds of playlists and different videos to help you wherever you are. And I hope I see you in another video soon.